Hello, today I'm going to tell you a little bit about one of ABB's best kept secrets, the unique Aquaprobe II electromagnetic insertion flow meter. We're on our way to a local water utility to measure the flow in one of their main feeds to a local village. Right, well here we are arriving at the site. There's actually no meter at all installed here, which is one of the reasons why Aquaprobe is the perfect solution, as you can actually install it without interrupting the water flow at all. First thing to do is see what kind of fittings there are. Here there seem to be saddle fittings, one vertical and one horizontal. Here we have the complete Aquaprobe installation kit, but let's think of the where and the why you would use an Aquaprobe. As I said earlier, it's a perfect solution for applications where the water utility is unable to interrupt the flow of the water. It's very good to monitor already installed full bore meters and for network surveys. Okay, so let's see what is an Aquaprobe. Basically, it's a flow meter on a stick. All the working parts are contained in this tip here. There's a small coil inside which generates a magnetic field inside the pipe. The water flows past this tip and the electrodes pick up the signal. No moving parts, so very low maintenance. Stable calibration. What do I mean by stable calibration? That once the Aquaprobe has been calibrated at our factory in Stonehouse, that it would maintain that calibration for many years. There are a few things you'll need to consider before installing your Aquaprobe. You'll need straight pipe, and you'll need about 25 diameters upstream and approximately 10 diameters downstream, and you'll need a valve to have been fitted to the pipe itself. Aquaprobe measures velocity. To measure the flow rate, therefore, we need to know the area of the pipe, and in order to obtain this we must measure the exact internal diameter of the pipe itself. We do that using this gauging rod. Take the rod and screw it in to the valve. Just take the spanner and just tighten that up until the line on your gauging rod here is in the same direction as the pipe line. Then open the valve. Make sure that the handle is parallel, so in line with the pipeline itself. Carefully push it in until you feel it reach the other side of the pipe. There we are. Slide down the slider. Then pull your gauging rod up slightly, turn it around 180 degrees so that the handle is still in line with the pipe but facing the opposite direction, and then slowly remove and measure the distance between the top of your slider and the base. We have 263 millimeters. And then slowly remove the rod. Pull the rod right out until it's completely retracted. Close the valve and remove the rod. Okay, so now I'm going to fit the probe. We're going to fit this probe into the centre line. This is normal. The only thing that you should be aware of is that with very high pipe velocities, this can cause vibration on the probe due to vortex shedding, in which case you would probably insert it into 1/8 diameter of the pipe. Let's open the valve and push the Aquaprobe carefully down until we feel it hit. the other side of the pipe. Pull the collar down and then just tighten that. We need to carefully pull the probe out to reach the centre line point of the pipe. If you remember, our pipeline was 263 millimetres. Half of that is exactly 131.5 millimetres. Something you also have to consider is that the electrodes themselves are already 30 millimetres away from the very tip of the probe, so that would leave us with a centre line point of 101.5. You need to align the probe so that the handles are in the same direction as the pipeline themselves. Just pinch the nut slightly tighter. Carefully loosen. And then you have your safety catch in place. Now we have the Aquaprobe installed. Let's connect up the transmitter and see what the flow rate is. As you can see, there is a flow rate here. This, however, isn't the correct flow rate because we haven't set up the electronics yet. Let's just connect the comms lead to the PC. There we are. There are 3 settings you need to enter into the transmitter. The first one is the size, and in this case we refer to the exact internal diameter of the pipe that you measured, which in this case was 263 millimetres. The FI and the FP, these are factors which correct for the fact that the probe is actually in the pipe. However, most important of all is the size. The other 2 factors you can find in the installation manual from the setting up chapter. For the size 263 millimetres, the profile factor works out to be 0.853, which you can see on this table. And the insertion factor you can calculate from this formula here, which in this case works out to be 1.048. Let's enter these factors in. So that's the size, the profile factor and the insertion factor. And we can see what the actual flow rate is. It's about 46 to 47 litres per second. So that's it. Job done in under 15 minutes. That was easy, wasn't it? The Aquaprobe is designed for clean water applications. It can be used for network surveys, for checking of meters, or as a temporary meter installation where the flow cannot be interrupted. If you install it carefully, you'll achieve a 2% accuracy. It can be used in diameters from 200 to 8,000 millimeters, and it's a measuring device which puts ABB in a whole different measurement arena.